Hey students, in this video I'm going to give a couple of examples from this assignment just to kind of clarify how it all connects or it all wraps up. So one thing I want to point out is that you're going to have two scenarios. You're going to have the standard form equations, and whenever you have standard form, it helps you find the HA just by looking at it. When you have factored form, it helps you find the VA, so horizontal asymptote for standard and vertical asymptote for factored form, and the holes. So with these two, we can also identify the domain. So that's one of the main differences. Now that you have seen it all, you need to understand when it's convenient to have it a certain form. So for example, for factored form, one of the examples you have on your paper is one that has x plus 5 as a numerator. And on denominator, you have x plus 5, x minus 4, and 2x minus 7. And on this function, whenever you are being asked to identify the horizontal asymptote, you can't just really look at a degree here. You have to identify the degree by thinking of, if you multiply these factors with each other, what would be the degree? So for this one, we're going to look at the degree on the numerator. And again, it's just how many x's you have on the top. Here we just have one. And then the degree of the denominator, which we have these three factors multiplied times each other. So we're going to have x times x times x, which will result in x to the third power. So the degree is 3. Here, this is going to be bottom heavy based on our notes. And when it's bottom heavy, we concluded that the horizontal asymptote will be y equals 0. So that takes care of the horizontal asymptote for factored form. Then for vertical asymptote, we would have to first find the whole to kind of cancel out the factor we don't need. So in this case, a whole is whenever you have the same factor on the top and bottom. That will give you a whole. So we're going to use x plus 5 equals 0. Then we solve by subtracting 5. X equals negative 5. That's how we will calculate the x value for that whole. To find exactly the point of the whole, we need to use the other factors and find what that will be. But it's okay if you just find the x value. At least you know where the whole will be at. The VA, vertical asymptote, can be found with the other factors that are left in the denominator. So we're going to have x minus 4 equals 0. And we're going to have 2x minus 7 equals 0. So we're going to add 4 to both sides. One vertical asymptote will be x equals 4. And the other one is moving this to the other side. So adding 7. 2x equals 7. Divide by 2. X equals, we can just put a decimal just to kind of estimate. So 3.5 or 7/2, whichever one you want to keep. So here, these are the VAs, and this is the whole. Just a visual of this is you will have a vertical asymptote when x equals 4. We will have a horizontal asymptote when y equals 0. So on the x-axis is your HA. There's a VA right here, and then at 3.5, so there's another asymptote right here at 3.5. And then there's a whole at x equals negative 5. So this is where the whole will exist. So with this, we can conclude for the domain to be the set of all x values such that x cannot equal the whole and the VA. So -5, 3.5, and 4. So these three values is the restriction on the domain. All right, so similar to all this, we're going to go ahead and do the standard form example. So this is in the back of the paper. On one side is the factored form, on the other is the unfactored form of the standard. An example for this one would be x squared plus 7x plus 10 over x squared plus 2x minus 15. So as mentioned in class, anytime you have a trinomial, you do need to factor these by using your x strategy, which is drawing the x, putting a times c at the top, b on the bottom, a times c at the top, b at the bottom. But before we factor, I just want to point out, just by looking at this, you can tell right away the degree for the numerator and then the degree of the denominator. So on this one, the degree of the numerator and the denominator are both 2, which means they're the same. So that means we're going to calculate the horizontal asymptote by y equals the leading coefficient of the numerator with the leading coefficient of the denominator. Leading coefficient being a 1 and then a 1. So 1 over 1, which results in 1. So the horizontal asymptote is y equals 1. That's what we will have if we were to graph that. Okay, so to continue now with the VA and the whole, we do need it in factored form. So we're going to fill in the x's, a times c for the top, it will be 10. And then the b value for that will be 7. So 5 times 2 is 10, and 5 plus 2 is 7. Because the a value is 1, we can simply just write these numbers here in our factors, and it will be x plus 5, x plus 2. For the denominator, we're going to have a times c, so that's -15. B value of +2. So here we have 3 times 5 equals 15, but it's -15, so one of these has to be negative. Because the answer is +2, when we combine these, we need a -3. So +5, -3. The a value is 1 again, so we're just going to put these numbers, -3 and +5 on the factors, and put x minus 3, x plus 5. So that takes care of factoring those trinomials. Now that we have a factored form, we can calculate the whole, and that will be through looking at the factor that is on the top and bottom. So these two are the same, and we're going to have x plus 5 equals 0. Help us find that whole. We solve for it, so x equals -5. That's where the whole will be. And then the VA, vertical asymptote, will be the remaining factor in the denominator. So x minus 3. X minus 3 equals 0. We solve that by adding 3 on both sides. So x equals 3. That's the VA. So a visual for this will be a vertical asymptote at 3. Right here at 3. And then a horizontal asymptote when y equals 1. So here's the horizontal asymptote when y equals 1. And then a whole when x is -5. So wherever you have -5, wherever the graph is, there will be a whole on -5. All right, so to conclude this, the domain will be restricted by the whole and the vertical asymptote. So we're just going to say all x values such that x cannot equal the -5 and the 3. And that takes care of 2 examples on this assignment. So hopefully these 2 examples help you understand a little bit better how to find these attributes.